Hello everybody, in this video we're going to talk about how to solve quadratic equations by the method of graphing. So a couple of vocabulary words before we get into it. What is a quadratic equation? It's just an equation that can be written in standard form, which is ax squared plus bx plus c is equal to 0. What is the root of the equation? It's just the solution of the equation. And another term we want to throw out there, since we're talking about graphing today, our solutions are the x-intercepts of our graph. So we're going to look at three examples, one where we have two real solutions, one where we have one real solution, and one where we have no real solutions. So we're going to be graphing in standard form today, so we're going to start off by finding the axis of symmetry. That's opposite of b over 2a. Use that value to plug in for x to find our vertex, graph the y-intercept, reflect it, we should be good from there. So our first equation is already in standard form. X squared minus 8x plus 12 is equal to 0. So I'm going to find my axis of symmetry, and we're going to say x is equal to the opposite of b over 2a. So we get x equals 8 over 2 times 1, which is just 2. So we get x equals 4. So now we can draw our axis of symmetry in there. And now let's use 4, and we're going to plug that in. So 4 squared minus 8 times 4 plus 12 equals 0. 16 minus 32 plus 12. And so we get negative 16 plus 12, which is negative 4. So that tells me my vertex is located at 4, negative 4. And we can put that right there. And now this, remember, c is our y-intercept. So we can plot that at 0, 12. And our graph is symmetric about the axis of symmetry. So we can reflect that y-intercept to the right side 2 units. Actually, it's 4 since our intervals of our axes are 2 here. So we're going to put a point right there. And now we can draw our parabola. Okay, so I'm going to draw mine in there, and I'm going to adjust it to where it fits as good as possible here. And that looks pretty good. So now we're just seeing where does this graph cross the x-axis, and we have an x-intercept at 2 and an x-intercept at 6. So we're going to say x is equal to 2 and x is equal to 6. So those are my two solutions to x squared minus 8x plus 12. Okay. All right, now let's look at number 2, and we got number 3 here at the bottom. So we'll focus on number 2 right now. We have 2x squared plus 18 equals 12x. Well, this is not in standard form yet. We need to subtract that 12x so we can set it equal to 0. So let's write this as 2x squared minus 12x plus 18 is equal to 0. And now we can go ahead and find our axis of symmetry. So x equals opposite of b over 2a. So we get 12 over 4, which is 3. So we can graph that, so that would be right in between here, right in between 2 and 3, or 2 and 4. There we go. All right. And so now we're going to use 3 and plug that back in. So we have 2 times 3 squared minus 12 times 3 plus 18. So this is going to give us 18 minus 36 plus 18. Okay. So if we notice 18 minus 36, negative 18, and add 18 to that, and we get 0. So we have 3, 0 as our vertex. So 3, 0 would be right there. And we have our 18 as our y-intercept. So we can plot that point, and then we can reflect it over to right there. So now if we notice what happens, we have our vertex on the x-axis, which means we only have one solution there, and our solution is simply x is equal to 3. So we just had one real solution. Last example, number 3, we have 1/2 x squared equals 6x minus 20. So once again, not in standard form, we need to move some terms around. So let's write this as 1/2 x squared minus 6x plus 20 is equal to 0. And let's go ahead and find our axis of symmetry. So opposite of b over 2a. And we get 6 divided by 1, which is just 6, okay? So our axis of symmetry, we can plot that right there. And now let's plug in 6 into our equation for x and see what we get. So this would be 36, half of 36 is 18, 18 minus 36 plus 20. So this would be negative 18 plus 20, which is 4. So we get 6, 4. And that puts us right there. Our y-intercept here is positive 20, so that would be right there. And that's 1, 2, 3, so we could reflect that over our axis of symmetry. And now look what happens. Our vertex is above the x-axis, and our parabola is opening up. So we are never going to cross the x-axis here, so we're going to say there are no real solutions. Okay? And that's how you could solve a quadratic equation by graphing.